Hello everyone, my name is Ruxana and today I'm going to explain my lab exercise 7, that is enabling secure internet access with NAT and PAT. The aim of this experiment is to configure and verify network address translation, that is NAT, and port address translation, that is PAT, on a router. This enables internal private hosts to access the internet securely while conserving public IP address and improving network security. Let's start by understanding the types of NAT. Static NAT. This type of NAT maps one private IP address to one public IP address permanently. It's mainly used for servers or devices that must always be reachable from the outside network. Next is dynamic NAT. This uses the pool of public IP addresses and assigns them to private IPs only when needed. Once the session ends, the address is released back to the pool. Next comes PAT, that is port address translation. This is also known as NAT overload. It allows multiple private IP addresses to share a single public IP by using different port numbers for each session. This is the most common form of NAT used in home and enterprise networks. So, as you can see, the topology diagram. This topology consists of two routers, two PCs, and one server. Router 1 represents the internal network gateway. Its fast Ethernet interface FA0/0 has the IP address 192.168.1.1 and it connects to PCs in the private network. Its serial interface S0/0/0 is configured with 200.10.10.1 which connects to router 2. Router 2 represents the internet side of router. Its serial interface S0/0/0 has the IP address 200.10.10.2 and its fast Ethernet interface FA0/0 connects to a server with IP 10.0.0.10. The PCs in the internal network have IPs 192.168.1.10 and 192.168.1.11, both using 192.168.1.1 as the default gateway. This setup simulates how a private LAN accesses the internet through a NAT enabled router. So let us talk about the configuration setup. So these are the configuration commands we are using. After assigning IP addresses to all devices, I configure router 1 for NAT and PAT. Setting up the inside and outside interface for router 1, that is interface FA0/0, IP address and IP NAT inside, interface S0/0/0, then the IP address as well as subnet mask, then IP NAT outside, and configuring the default route, IP route 0.0.0.0.0.0 as 0/0/0. Then for PAT, access list permit 192.168.1.0.0.0.0, IP NAT inside source list, interface S0/0/0 overload. This allows all private IPs in the 192.168.1.0 network to share the single public IP 200.10.10.1. For static NT, IP NAT inside source static 10.0.0.10 200.10.10.2 IP address is used. So these are the commands we have used. This command maps the internal server's private address to a public IP, allowing external users to access it. So now let us come to the output. So here the interface IP address subnet mask default gateway for all the routers and the PCs are given. After configuration, I verified the setup using several tests. After configuration, I verified the setup using several tests. First, a successful ping from the PC to the router confirmed basic LAN connectivity. Next, I pinged from the PC to the external server, which also succeeded, confirming that NAT translation was working correctly. I then used this command show IP NAT translation, then show IP NAT statistic. These display the translation table showing which IPs were mapped to the public IP and statistics confirmed active NAT session. So this topology configuration were successfully executed. NAT and PAT were implemented correctly, allowing private hosts to securely access the internet using a single public IP while conserving address space. To conclude this experiment, it helps us to understand how NAT and PAT work to connect private networks to the internet securely. NAT not only conserves public IP addresses but also hides internal network details, adding an extra layer of protection. So, this lab provides valuable insight into how real world routers make secure and efficient internet access for multiple users. Thank you.